Hi, does anyone else want to know whether you can short the output of this thing without destroying it? I certainly do. Currently got 10.15 volt on the output. The current limiting is set roughly at an amp. So I'll grab this lead, which is connected to the output, and short it to ground. Yes, you can. That's the current limiting LED. Bam. And the output's dropped to 1.1 volt. That's without a short. Cool. Let's be dangerous. Let's wind it up to the full voltage, which is 19.5. Take my lead. 1.2 volt is what it is with shorted. LED is lit. No short. Let's wind the current limiting all the way up. Take my lead. Yes, we're at about 1.8 volt thereabouts. LED is lit. Yes, you can short the output on this and not kill it. Isn't that special? Greetings, the Astro 30 here yet again on this power supply project, and welcome to part 6.
Good news, everyone!
The PCB has been routed. I spent 4 hours this morning painstakingly doing it. I usually manually route, I don't use auto route because it has its own problems. But manual routing is a lot harder. So here's the 3D representation of it. It looks quite nice. It's double-sided, of course. It's probably not the best layout job I've done, but it works. The only thing I find annoying about KiCad is it doesn't have 3D models for every component in its library. So this 555 timer and this TL071 don't even have a black box representation of there's the fact there's an IC there. And there's this 1K trim pot, so it's kind of annoying. But yeah, you'll notice up here I've got a orangey coloured capacitor, 1 microfarad 35 volt. Well, that replaces the 10 microfarad 63 volt at the output of the LM317T. It's a tantalum capacitor, and that's what the datasheet does actually recommend for the 317T, is to put a tantalum capacitor on there. I did verify you can use a 1 microfarad. Normal applications say 10 microfarad tantalum. Unfortunately, J-Car only sell 10 microfarad at 25 volt and 1 microfarad at 35 volt. So at 25 volt we are getting close to the limits of that capacitor. So I went for a 1 microfarad 35 volt, and yeah, that's what we're going with. I'm going to use the Panasonic relay that J-Car sell for the load switching. It seems to be a functional relay, good for the purpose. I've left a little bit of room here on the BD139 around components to put a heatsink to it, a little TO220 heatsink package on it. Unfortunately, J-Car only sell the 19mm wide one. They don't sell the smaller version anymore. I don't know why they keep removing products that they used to sell that are quite handy to have, and then they don't have them anymore. It's kind of annoying. But anyway, it is what it is. So I'll have to order some separate heat sinks, probably from China, of the correct width, which is around about the 15mm mark. So 15mm, 9 on the fins, and it's about 19 or so high, I think they are offhand. I'm using the KBU 406 rectifier bridge. I've given the original person credit as to who designed the regulator and pass transistor setup, where the circuit came from. I gave Philip Chugg credit on my PCB because it is his intellectual property, even though half of it comes from the actual datasheet application information. Now you notice down here I've got the pots for the voltage and the current mounted on the board. However, you can simply put one of these three-way connectors in their place and actually have them off board. I just put them on the board so everybody knows what that's for. But again, it can be separated. These LEDs can also have connectors put on them. They've got 0.9 of a millimeter size hole, and these JST connectors have actually a 1 millimeter hole. It'll be a bit tight, but you'll be able to get them in there. I don't have any spare ones to verify that, because I do have another board that uses those connectors, but I've only got the plugs. I don't have the actual headers, which is annoying. So anyway, the Gerber has been uploaded to PCBway, and it is going to cost me $24.40 American. It's about 140 grams in weight. This is without the shipping. Add an extra $6 to $7 US for shipping, so it comes out to about closer to the 29 mark when all said and done. So that's going to cost me about $52, $53 Australian. So I'll order these up next week and have them produced and sent. I've got some other boards down here that need to be produced, but I'll do them later. So that's their Gerber to image view. Doesn't it look pretty sexy? Ooh, yeah. That's a basic representation of what it looks like, and that's the top. And here is the bottom. We always like looking at bottoms. Now. Alright, so I'm going to stop waffling on about the PCB and actually get the thing paid for and actually produced and sent. So this video will be about 2-3 weeks away by the time it gets uploaded.
Good news, everyone!
Okay, after a little bit more than 2 weeks, the PCBs are here. I'm not feeling the best at the moment because I've just had some bad news yesterday, so but I'm going to work through it as best as I can. Let's get this box open, shall we? Ooh. There they are there. Not as decently packed as usual, but ooh, sexy. Alright, let's get the packaging open. They're well packaged. Difficult to get it open. God, blimey. Come on. Oh, there we go. Ah, finally. Nice. There it is there. Looks pretty sexy, I think. Everything's looking good. I hope it works. I checked it 3 times for routing to make sure it was correct. Pretty sure it is correct. There's the bottom. As I said, we like looking at bottoms. Yeah, that joke's a little lame. But no, I hope this works out a little bit better than that power amplifier I built recently. I just want to make sure I've got the right relay footprint. I'll just double check that, and I have to make a correction. This should be a KBU 604, not a KBU 406, so it's marked incorrectly on the silkscreen, but it's correct on the bill of material and on the schematic. So I'll just make a note of that when I release this PCB as a project available for download on PCBway to make that correction. However, it's neither here nor there. So I just need to double check that relay. Yep, it's the right footprint, fits perfectly. Very good. Okay, and this is the heatsink I'm going to be using. It's a HH8570. So I'll just open this one up. And the way this one's going to work is it'll sit at the back of the board like that. The LM317T will mount through a screw hole here, and the main transistor in the middle of the fins here. And I'm going to use some little PCB angle things to actually secure it to the heatsink to give it a little bit more structural rigidity. So it'll probably hang out from the heatsink about a couple of mil or so, but that's alright. And then those will be mounted to the standoffs underneath on all 4 corners, just the angle bracket things. so that it can also mount to the inside of the case. And this heatsink will sit up probably around about the 5mm mark is where those holes are going to go to mount to the bracket or brackets, so that it's not actually making contact with the inside of the case, which will be plastic. But that's later down the track, much later, and I don't know when I'm ever going to get to it. But the main thing to do now would be to actually build it and make sure it works. So let's get cracking on that. Okay, so I've got all the 1/2 watt resistors on there that I need to put on there, I believe so anyway. Looks like it. What I'm going to do is I'm going to build everything up apart from the output transistor and the regulator IC and the op amp. I just want to do some preliminary testing, especially on this 555 timer circuit. And I do have a 79L05 now, which I got from China, 10 of them for like $1.95. They're actually WS 79L05s, so I'm a bit dubious about them at the moment. But yeah, I'll put everything else on, like the diodes, the capacitors. I'm not really worried about these two large resistors yet. But yeah, we'll get it up to, I want to just basically be able to test the main voltage rail and the -5 volt reference rail. So that's the story so far. Starting to look like something. Got the IC sockets in, the diodes. Now I can move on to smaller profile semiconductors like transistors and the regulator IC. Check it out. I'll put this transistor proud of the board as high as possible so I can get a heatsink on it. I'm still waiting for those. Don't know where they are. I hope I don't have to replace that regulator. I'll be so pissed off. Anyhow, I've got the connectors in, well, some of them. I've run into my first roadblock. I need a 47 microfarad 63 volt capacitor there. Fuck, why does this have to be so fucking hard? That's what she said. And for some reason I've got a 47 microfarad 16 volt, and that was in my test circuit. I'm surprised the bastard didn't blow up. Well, okay, I'm going to have to go out to JCar and actually get a 47 microfarad 63 volt because I don't have any. Great. I'll do that tomorrow. Anyway, it's starting to come along. I'm going to continue putting some more parts on, and yeah. And there we go. It's about as far as I can go because I don't have that capacitor that needs to go there. This AC input socket is really close to this bridge rectifier, so I had to bend him over slightly just to get the plug to, you know, still have some flexibility there so you can get the connector undone. Probably won't be that much of an issue, but probably a note would be to actually have this bridge rectifier slightly higher on the board. I've got the 5 watt resistors in, the relay in, everything in but the ICs, and of course that capacitor, which I don't have. I'm still surprised that it didn't blow up. Don't know why. Limit LED is a connector, obviously, because it needs to go to the front panel. I haven't got the output connector because there's something that has to be specially done to that, because it has to go in series with that panel meter. And yeah, so it's assembled as far as I can take it tonight. So I'm just going to have to get a 63 volt 47 microfarad capacitor to continue, and then do some preliminary wiring to the transformer, which is sitting over there ready to go, and then we can do some testing, see if we have the voltages that I need for the circuit to operate correctly. However, that's sort of what it looks like when it's assembled. Yippee-ki-yay, motherfucker. Okay, it's up to the testing phase for this little module now. Got my multimeter there. I'm going to measure some preliminary voltages. No IC is installed, so all I want to know is, first, is there, you know, 12 volt roughly at the, I think it's pin 7 or maybe pin 6, I can't remember now, I have to quickly look at the schematic. Right, at pin 8 of this 555 timer, not that it's in there, but at the IC socket anyway. I want to make sure that there is roughly 12 volt at the emitter of this BD139, which is the pin here on the left, and check a few other things. So first, I'm going to power it up by plugging it in and see if anything goes off with a bang, which I hope it doesn't, because this is the first time I've powered it. So here we go. Well, nothing went off with a bang. Now I've got my meter connected to the ground of the circuit, so I'm going to go to pin 8, which is here. We've got 11.62 volt. Nice. At the emitter of this transistor, we've got also 11.79, so I know that's working fine. I don't know if I've got my negative 5 volt reference yet, but yeah. So next thing to test would be, I'm going to plug an LED into each of these ports here and see if it lights up. Well, it won't in the load on, but at least the power on. So if I plug this into the power LED position, if I can so get it in there, it is a light, but I can't get my fingers out of the way. There we go. Yep, that's lighting up. Okay, beautiful. So now what I want to do is I'll move this LED over to the load on section position. If I can so get it in there, like so. And I'm going to short this connector, which is a switch anyway. I'll just use the multimeter probe for that, and both the LED should come on and the relay should engage. Bingo. So I don't know how hot that transistor was getting. Doesn't feel like it's getting very hot at all. The meter, funnily enough, is measuring 9.35 volt across that switch. And I've got my finger on there now. It's not getting hot at all. So that's good. Right, so I know that that part of the circuit is working. Do that again. So it's measuring 9.38 volt between ground and that switch. So that means in totality it's probably about 9 volt going across that relay. I could verify that if I could make that stay on, but I can't right now because I haven't done the plug end for that connector, so I can just short the ends of the wire together. Although, I don't know if I can get one of these little clip leads just to clip in there and short. Okay, so if I measure across this diode at the anode after I untangle it from the transformer, nothing. Nothing, interesting. Because it's the wrong diode. Yeah, that, if it would stay on there, there's our 9 point, stay on there. There's our 9.36, 9.37 volt. That's where that's coming from. It's basically what is going across the relay. Okay, so we know that that is all working fine. And yeah, okay, that transistor's starting to get warm. So I won't do that for too long. So I'll unplug it now. Because the next stage is I'm going to insert the 555 timer, and then I'll measure the output voltage of this regulator on pin 3 to see if we have -5 volt. Here's the IC. Make sure I insert it the right way around, because otherwise I'll blow the hell out of it. There we go, IC is in for the first time. Okay, so I'll plug it back in there and hopefully the IC doesn't go off with a bang. Well, it shouldn't, because there's only 11 volts there, almost 12 volts. Now with respect to ground, I do indeed have -5 volt there, so these regulator ICs that I bought for cheap are working fine. Actually, I could have just measured on pin 4 of the op amp IC. So that would have made more sense. Because it connects to the same place. I mean, well, it's pretty bloody obvious when you think about it. So now, what I should do is I should measure what is coming off of the collector, is it? Where this transistor normally goes. To see if I've got the full line voltage going in. I think it goes in the collector and comes out the emitter, or is it going in the emitter coming out the collector? No, it's going in the collector coming out the emitter. Okay, so I need to put it on the center pin. That's the soldering line. Well, that can't be right. That's because I'm looking at the wrong part of the schematic. Duh. No, it's going in the emitter. Just making sure nothing's getting hot. Shouldn't be. So the emitter, which is on the right, boom. We got a good healthy 20.5 volt there. I should have done that in the first test, but so far this module has passed its first tests. Now all I've got to do is make it pass its final tests. So the next thing to do now is to fabricate up the heatsink. That is, drill the holes to make it fit, and then put the output devices in, including the op amp, and test to see whether we've got a variable voltage supply. I might do that a little bit tomorrow because I've got to wire up the sodding cables here for the controls. I hate those mini little connectors, they're a pain in the ass. Anyhow, that'll only be a few seconds for you, and we will get into doing the heatsink now. Right, for mounting the PCB to the heatsink, I'm going to use these angle bracket PCB standoffs. They're the HP0872, and they're tapped with an M3.5 hole, which obviously I'm not going to use because I don't have an M3.5 millimeter screw. So I'll have to just drill off the top of the bit of metal that sticks up that the tap is in, which I think you can just see there. Drill that down with a bigger drill bit and make it flat. Got the heatsink masked up ready to mark and drill. Alright, a little time later I've worked it out. We come in 12 millimeters from the edge here and 30 millimeters up for the regulator IC and the transistor. 52.5 millimeters in from the edge for the transistor. 15 millimeters up for where the standoff angle bracket screws are, and 4 millimeters in from each edge for the holes for that. So it's just 4 holes, got to drill them, and yeah, I can't get it to focus. Focus, you bastard. Alright, and there we have it there. All those holes are drilled to 3.5 millimeter because my 3.2 millimeter drill bit is blunt. No incidents. Yeah, I did hit the fins with the drill bit as it went through, but it's not really that much of an issue. Yeah, it's marred the surface, but once it's inside a case, it's not going to be seen anyway. So now, as you can see, I've got the standoffs on the board here, the angle brackets, and I've drilled out those protrusions that they put the taps in. Yes, transistors are sort of like sticking in the holes. So I'm going to bolt this heatsink to the brackets and see what it looks like. Okay, the brackets are slightly off, like they're pointing a little bit inwards, but that's okay. The metal will succumb to that. The issue is because there's a lip here on the back that the nut sort of like sits up against it, so it can't move over that way any further, which is a bit annoying, but it is what it is. As we can see, we've got a gap there at the back of about 2 mil or something, and from the desk a good 2 mil, so it'll clear the bottom of a plastic case just nicely, so that the heat generated by this heatsink isn't melting the plastic case, which would be bad. And so I can mount the regulator IC and the transistor with the heatsink removed from the board, bring the board up to the heatsink and transistor combination, and then screw these in, the brackets and the nuts tight, and then solder the leads. For that LM317T, just enough lead length, I think, for the height I've put it. Actually, it's not flat with the heatsink, so I'm going to have to give them a slight bend, sort of like that. So they've just got a slight little angle bend in the middle there so that it brings the device that much closer to the heatsink flat. Same as with this transistor. I mean, it's not perfectly straight, but it'll do. I'm still not really liking those angle brackets being at an angle. Haha. No. Yeah, there's not much I can do about it. The screw itself is right over towards the other edge of that bracket on either side, so there's not much I can really do about that. At least I don't think there is. That's a bit better. I just loosened the hex end off and let the bracket relax into the position it wants to be in. As we can see, this screw, well, it's still more central, but it has moved a little bit. It's not exactly in the center, but at least the brackets aren't at a complete angle anymore. So yeah, that solved that little issue. Okay, so I did notice that my LM317T is over at an angle, so I've measured that a little bit incorrectly, but it is what it is. Okay, so let's get to finalizing the construction. Okay, guys and gals, check it out. It's finally assembled. I've got the limit LED installed, got the pots installed, done these sodding connectors, which are a pain in my ass, but they're done. Now, I was thinking about this relay. When I connect the panel meter up and it's drawing more current off of this transistor, I still don't have the heatsink yet. Remember, we had about 9.37 volt at the relay. Once I connect the meter, I don't know if that's going to drop any further. It probably might. The thing is, these relays will not pull in with any less than, I think, 7.5 volt. So I've got to be mindful of that, which may mean I might have to up that 12 volt Zener diode to probably a 15 volt Zener diode just to give it enough voltage buffer there. Now, I probably could have used a 7812 there for, you know, regulation for the 12 volt rail, but I didn't. Alright, now let's get this thing tested, see if we've now got a variable power supply or a voltage to smoke converter. Okay, I've got the load switch shorted. I believe I've got it shorted, so I should get an output as soon as I plug it in. Okay, I'm always dubious about powering up a new circuit for the first time because, well, I assume my routing's correct. I checked it 3 times before I sent it off to be manufactured, so it's all routed correctly. The only other thing that can be an issue is probably having a component backwards or something, but let's plug it in. Oh shit, that scared the crap out of me. The solder fell off the soldering iron stand. Well, we've got 13 out. And we've got a variable voltage. Look at that. 19.5 volt there. And almost 0. I need to adjust that trim pot. I'm just going to play with the current pot, see if the LED comes on. Yes, it does. We have current limiting. Nice. So everything's wired correctly. Alright, now I'll see if I can trim out that offset voltage there. It's very touchy. I want to get it almost 0. A few millivolt isn't going to really hurt anything. But it's... oh, I overshot it. Watching video of me adjusting a trim pot and not saying anything. That's about as close as I can get it, and it's bang on 0. Cool. So far, it's working. So, what I need to do now is put a load on it and, well, yeah, see how well it works. So I'm going to grab my test light from up here and just put that somewhere on the bench here, and I'm going to hook the negative up. If this would sit still for me, it's not going to, it wants to be a prick, so okay, be a prick. Go like that then. So I'll connect that to negative. Just want to be careful that that doesn't short. Not that it's going to hurt it, it will just limit the current. I just don't want to short it because it's not worth the effort, and I don't know how long you can sustain a short circuit. So I'll connect up the test light. So now I'll wind up the voltage pot, and we are now at around 12.2 volt. So I'll just disconnect my load. Still 12.25 volt. Reconnect the load. Still around the 12.23 mark. That is awesome. It is actually working perfectly and correctly. So I'll just turn the load off. Yes. On. And not much voltage variation there. Perfect. Right, now last test, current limiting. Boom. Limiting down to 1 volt. There's no variation when I maximize it, so yeah, that's perfect. That's absolutely perfect. The transistor's not that hot. The other voltage driver transistor, I mean, it's warm. Heatsink's cold. Cold, cold, cold. Transistor's cold. So I'm going to soak that. I'm going to leave it powered up for about 5 minutes and then come back and do a heat test. Okay, it's been a good 5 minutes. The voltage may have dropped off by about 50 millivolt or so, but that's alright. Still driving the load fine. Now do a heat test. Well, the heatsink is starting to get warm. I can feel that. That transistor that's driving the relay is still slightly warm, but not hot. The one that's driving the 555 timer here is warm to the touch. It's actually hotter than that one, probably by about 5-10 degrees. But I can stick my finger on it and keep it there. It's not burning my finger, so that's pretty awesome. So there we go. A variable lab power supply, 0 to 15 I'm going to max it out at when it's loaded, but between 60 mA and, well, 5 amp depending on the transformer you use, working perfectly. I can't fault it. The 555 timer is cold, the op amp is cold, the test light is red hot, but yeah, what do you expect? You're not supposed to really have a test light driving that long. Anyhow, this will be revisited later and put into a case, but for now, I'm going to leave this video here. So if you enjoyed it, please remember to go down below and rate, comment and subscribe. And you can also follow me on Facebook and become a Patreon supporter for as little as $1 a month. Hit those links in the description, guys. Anyway, I'm going to say goodbye. Have a great day. I love when shit works first time out the box without any problems. Wow, look what it did to this test light. Yeah, I'm pretty sure that's probably buggered now, but okay. I'll see what happens when it cools off. It did get quite hot.